Have you ever wondered everything you need to know about trigonometry and how this is good applicable to various understandings in mathematics? Here are the 5 things to note about trigonometry. One is the following. We're going to be looking at angle measurements, and this will be supported by understanding the basis of unit circle. And this unit circle understanding will enable us to discover various interesting concepts involving trigonometric functions, and most importantly, how this is going to build on itself to produce identities. And this will allow us to not only explore these functions on a right angle, triangle, or right triangle, but finally we're going to see how this is going to be important in understanding arbitrary triangles. And so here are the things that we're going to look at in detail. First, angle measurements. In here we have to look at a couple of facts to remember when it comes to measurements, and the facts include the following. When we have a specific circle that is not actually the best drawn circle as you see right now, we actually need to remember that yes, pi is equal to what? 3.14 approximately. We have like 159 and so on. Now the question here is, why are we introducing this particular pi constant? The reason why we're introducing pi constant is because we need to introduce another important unit, which is called radians, and we're going to relate radians to that of our other unit, which is degrees. And we know that to make a full revolution, which means starting from this particular point here all the way to the same point where you start, which is a full cycle, this here is equal to 360 degrees. Now this in terms of equivalence to radians is equal to 2 pi. And this here, remember, when we divide by 2, what happens in this case? Divide 2 by both sides, we come up with another interesting observation in terms of what is 1 radians. And once you know this, you should be able to relate it to the circle. 1 radians is equal to what? 180 over pi. Reason why is pi, because we are actually dividing both sides by pi. So how is this reflected on this particular circle? And in order for we to do that, what we see is that if we have this to be one full cycle, then half of 2 pi is going to be equal to 180, which is what we see right here. And so from here all the way to here is going to be highlighted as r pi, and remember that this represents r 2 pi. So this is one thing to remember or to be aware of when it comes to relationship between radians and degrees, where you have 1 radians, and so 1 radians is equal to 180 divided by pi. And therefore you can also say that indeed our specific pi radians is equal to 180 degrees. Now the next part here is, what if we have another specific relationship, which means that we are dividing both sides by 360. What happens is that we're going to come up with another relationship with respect to 1 degree. And here we can conclude that 1 degree is equal to what? Pi over 180 radians. And so when you zoom in, this is what you see right here when you have your 1 degree to be equal to pi over 180, and this here is reflected as the radians for 1 degree. Next is we're going to look at unit circle analysis, and unit circle analysis we're going to introduce you to an understanding of a concept where we're going to look at this particular plane, and we know that this here is our y, this here is our x, and this is our circle right here. Now looking at this circle, we notice a couple of interesting things right here in the circle. We notice first that from this particular point here to this particular point here is represented as a value that is well known in circles to be called the radius, which is expressed as r. And so since from here to there is r, and we can pick another r, which in this case is this here, which is represented as r, the two r's here make, or they create a space here that is going to be represented as the symbol, which we all know to be called from here to here theta. And so this theta is represented as the angle that these two r's make with each other. Now we're going to make a relationship between r and this particular theta, and the relationship between these two variables is going to be instrumental in determining two things. We need to determine one, which is called the arc length, and the arc length is expressed as the distance from the circumference of one r to the other r circumference, which is from here to this particular part right here. Now this arc length is expressed as the relationship between the r and the angle, and this relationship is the product between our r and our angle, which is expressed in this case in radians. That is something to keep in mind, not degrees. Next is another concept which is going to be derived from this same relationship as shown right in this particular space, and this space here we're going to express it as the area of the sector, and the area of the sector is expressed as what? Is expressed as half multiplied by r radius squared multiplied by r degrees, theta, which is expressed in radians. And so these are the two things to keep in mind when it comes to the sector of a circle. One is the arc length and the area of the sector. Now in part B of this particular unit circle, we're going to highlight a couple of things in this circle. Now remember that from this origin spot here to this particular section where we have our x to be touching the circle, this particular length here is going to be considered as the value 1, because that is a unit circle and that is the length of that arm. And this arm here in this particular point is going to be represented as the coordinates a to b, where x is 1, y is equal to 0. Now this here is really important in terms of assigning this as our starting point for our unit circle. And one thing to remember is that by creating a sector, let's say that this arm is going to be moving all the way to this particular spot right here, and this is the new position of our arm, which is represented as the coordinate b. And this particular part here, we can now recognize that there is an angle made from here all the way to here, which is represented as theta. So what we need to recognize is that for our limit of theta, theta has to be in the interval of 0 included to 2 pi, which is in this case not included. So that is something to keep in mind for the interval in a unit cycle. We now are going to create a relationship with our cos, which is our trig function, and that of our sine. And by convention, remember that our specific points, let's say for example point B, its coordinate which we need to address for our x is expressed as cos theta, and for our y, its b's y is expressed as sine theta. And this is applicable to any point around this particular unit circle. And once you're able to recognize this, then we can now express our x to be the x coordinates to be cos theta and our y coordinates to be sine theta. And once you have this, how about we want to extend this periodically? Let's say for example we make one particular cycle around, and then we make another one, and then we make another one. We need to remember that for our first trip, before it is completed, it is represented as where n is equal to 0. That is for our before first cycle is accomplished. And how is this reflected on our specific diagram? This shows that currently this particular arm is at B and is not yet completed its first cycle. So therefore currently it is at n equals 0. Therefore once this accomplishes the first cycle, our B is going to completely get to this particular point, and now it is currently at n equals 1, which is at this particular position right here after it's made its first round trip. And so this here, when we extend our B to any periodic system, this here is going to be for our x coordinate. Our cos theta is equal to, for example, when this particular arm has made, let's say, n amount of cycles, it means that our cos is going to be applied to 2 multiplied by n multiplied by pi plus theta, and this here is extended to what is the y coordinate, and the y coordinate for that n cycle for B is equal to sine theta, as it applies to sine 2n, the same n cycle, times pi plus theta. And remember here that theta is going to be represented in radians, and keep that in mind, not in degrees here. And so once you're able to accomplish this, then we are able to determine the coordinate for B for any number of cycles that you are given in any question.